So probably the most important innovation in cooking in the last 200 years is low temperature cooking. You can buy what's called an immersion circulator, a unit like this, that can keep water extremely accurately heated. So this does within 1/10 of a degree or so Celsius, keeping a very accurate water temperature. A very good demonstration of that is eggs, because eggs almost can act like a thermometer, and in a very small window of temperatures between 57 Celsius and 70 degrees Celsius, that 13-degree window is almost all of egg cookery is encompassed in those 13 degrees. So at 57 degrees Celsius, in an egg, it's completely raw. However, if you cook an egg at 57 Celsius for enough time, I usually cook it for an hour, it's completely pasteurized, meaning you've killed any salmonella in it. And at 60, it's just barely set. You can see some, and remember, the white is made up of more than one kind of protein. So what we're doing is we're setting some of the proteins, but not others. And it's 2 degrees higher than 60. We hit the first real egg that we use in restaurants all the time, the 62-degree egg. This is the perfect egg for Eggs Benedict. Now look at that. Only 2 degrees difference. Look, the color has changed on the white. It's a lot, it holds up, but it's still got kind of a custardy, delicious, soft white, right? But notice here that the egg white, there's 2 different kinds of egg white. There's thick and thin. And the thin, right, sets in a different layer from the thick and almost acts as a release agent. And when you cut it, the yolk is still runny like this. This is perfect for toast. Only 1 degree higher than 62 is one of the eggs that I think is most interesting. 63 Celsius is what I like to call in-betweener eggs. So you can see here is a yolk that is not yet set and is somewhat liquid and will eventually run out. All right, so 1 degree higher than 63, we have 64. 64 is actually a fully set egg yolk, but it's still extremely soft and custardy. So if I go 1 degree higher to 65, you start getting into what I call the Play-Doh egg yolk. At 66 degrees, it's kind of not Play-Doh anymore. It's more like marzipan. It comes up nicely, but it's still extremely moldable and creamy. 1 degree higher than that, 67, and you start to lose that effect. So if you look at a 67-degree egg, begin to squeeze it, you can see that it shatters here, it pops. Instead of, it's beginning to lose its creaminess, and it's starting to take on the kind of crystalline nature of the inside of a cooked egg yolk. 3 degrees higher than that, at 70, it's like a hard-boiled egg. One of the interesting things is that a 70-degree egg, if you only cook it for an hour or so, doesn't have any sulfurous aroma at all. It's completely fresh. There's no greening of it, right? So it's a very bright, beautiful-looking egg yolk. And when you break into it, you'll see that it is got the cooked granular structure now of a standard kind of hard-cooked egg. As you can see, from raw but pasteurized all the way up to hard-cooked egg yolk is a mere 13 degrees, just to kind of demonstrate the importance of temperature control.